we have a similar situation, but now the string is not parallel to the inclined plane, it has an angle, but it's still hooked up to the wall. And they still give us alpha. So they've given us the mass, they've given us alpha. What do they want? They want the normal force and the tension. It is obviously stated at the top in the title that the system is at equilibrium. Therefore, equilibrium means Newton's first law. So all you have to do is apply Newton's method, identify all the forces, add them up, solve for them. That's it. Equilibrium concept is going to represent 60% of the next class, C270. That's all there is to it. So we definitely want to master it now, and it will come back in chapter 12. So more than half of the content of the next class is just that, nothing more. The only the difference is you're going to go from 2D to 3D, but the mechanism and the technique is the same. So make sure that by the time you complete this class, you want to be C and ME majors, you master this topic. So let's do a free body diagram. We have the weight, we have the normal force, and we have the tension. Let's redraw this from a zero-dimensional point. Weight, N, and N is perpendicular to that surface. I'm going to put in dot, because that's where my alpha is defined, and T. And T is given to us from this alpha, this beta. So, obviously in this case, there is no force that are perpendicular to one another. So there is no X and Y, which is an orthonormal coordinate system that will have more than one force. Hence, remember the second trick. If that is not the case and you have more than one angle, pick a coordinate system such that at least one of the two axes is along the direction from which your angles are defined. Hence, for us, going to be that one. Let's call this one Y and perpendicular X. All right. So I need to add those three vectors. I need to therefore express them in componentation. N is trivial. T is trivial because beta is already given to us and we chose Y to be where it was defined by. Easy. So we only have to figure out W. W is a similar case as before. W is obviously perpendicular to the horizontal line that creates your angle alpha. So let's look at the other line and ask ourselves, is this line perpendicular to X or Y? In this case, X. Therefore, alpha is between your angle and X. And that's it. Now we can express this the two-dimensional problem, therefore two equations. We're going to have Tx, which is T cosine beta, plus 0, because N is anterior to Y, minus mg sin alpha, and that's equal to 0. The Y, if one is cosine, the other one is sine. If one is sine, the other one is cosine. We just have to figure out the signs. Ty, oh wait, that was my y-axis and my x-axis, sorry. Is that correct? T cosine positive, yeah. So the x component of my t is therefore negative, because I choose positive x to be down. My n is also going to be negative, and my cosine mg is going to be positive. Done. Before we solve, let's do the check. What are the unknowns? If we know m, then we know mg. Therefore, the two unknowns are n and t. Okay, not bad. So let's practice a little bit of algebra. Let's use the substitution method. I'm going to solve for t from equation 1 and substitute into equation 2 to get the n. So obviously from equation 1, t is mg sin alpha divided by cosine beta. And then as I'm going to substitute this in the second equation and solve for n, I'm going to have n is equal to mg cosine alpha minus t, which is mg sin alpha divided by cosine beta, but times sine beta again, so that's just tangent beta. And you can even factor mg. Uy, oh, wait. Wrong number. Mg. Done. And again, cosine alpha, as you plug numbers, better be bigger than sin alpha times tan beta. Otherwise, we got major trouble. Okay, remember, all your answer must be positive, positive, positive. Questions? Questions on the concept of equilibrium. As you can see, straightforward is just Newton's first law. Nothing new under the trees. It's just a fancy word. But it is an important keyword because it will come back in chapter 10, 11, 12, especially 12. And we're going to revisit its definition. Yes, we know tangent beta because beta it was given to us, right? It was 10 degrees. And thank you. I forgot to put it on our list of known value. Sorry about that. Thank you, Ray. Okay.